So welcome to Everyday Mathematics. Today we're still on the 2021 Universal Florida Integration B qualifying round, and we're moving forward to part 4 where we'll be looking at problem 14, 15, 16, 17, 18, 19, and 20. So these are very interesting problems. I hope you stick around and see how we're able to solve them. Now, before we move forward, I'd like to encourage those of us who are here for a first or second or third time but haven't subscribed, to consider subscribing to our channel here at Everyday Mathematics. What we do is we go around and about and look for interesting problems, and we come back and share with you. So without much ado, let's jump onto the solution phase of our problem set. So on to problem number 14, the indefinite integral of the square root of 1 minus x over 1 plus x. So the important thing here is to try and simplify this fraction. And the proposal here is to multiply both the numerator and the denominator with the square root of 1 minus x. So what happens here is, as shown here, we could isolate the numerator and take the square root of 1 minus x as the numerator, square root of 1 plus x denominator, and if we multiply both the numerator and denominator with the square root of 1 minus x, then we get 1 minus x square root times 1 minus x square root over 1 plus x square root times 1 minus x square root. The numerator obviously becomes 1 minus x, but the denominator then becomes the square root of the product of the difference of two items, which is 1 plus x and 1 minus x. And as we know, this becomes 1 minus x squared. So what happens next is we can go ahead now and say our problem is the indefinite integral of 1 minus x over square root of 1 minus x squared. So what we could do, we could try and separate this into 1 minus 1 over square root of 1 minus x squared minus x over square root of 1 minus x squared. It is easy to see what the solution is here. For those of us who have memorized these integrals, it's obvious, but for those of us who haven't, we could do a variable transformation where we say, okay, let x be equal to sine theta, such that the derivative of x with respect to theta, dx d theta, is cosine theta, and that means that we can substitute for dx with cosine theta d theta. So we can go ahead now and substitute our equation, since we have 1 over square root of 1 minus x squared minus x over square root of 1 minus x squared as our integrand. Then now we have, in place of x, we have sine theta, so that we have 1 minus square root of 1 minus sine square theta minus sine theta over square root of 1 minus sine square theta. And then in place of dx, we have cosine theta d theta. And so square root of 1 minus sine square theta is same as cosine theta. And so we have 1 over cosine theta minus sine theta over cosine theta times cosine theta. The cosine theta in the denominator cancels with the cosine theta that is next to d theta here. So that now we have the integral of 1 minus sine theta. So integrating 1 minus sine theta gives us theta plus cosine theta. And since we said that x equals to sine theta, we can see that in place of theta here, we have x sine sine x. In place of cosine theta is the square root of 1 minus sine square theta. So since x is sine theta, we have square root of 1 minus x squared. So the answer for integration here is x sine x rather, minus plus 1 square root of 1 minus x squared, and plus integration constant c, obviously. So that's our answer. So on to problem number 15, the indefinite integral of square root of x squared plus 8x. It's kind of interesting, but what we could do here is we could express the square root of x squared plus 8x as the square root of x plus 4 squared minus 16. And so using the identity, we're going to use hyperbolic functions here. So cos squared t minus 1 equals to sinh squared t. So that this x plus 4 squared could be expressed in form of 16 cos squared t, so that we do have this expression condensed into a simple function. So that's what we did. We're going to say let x plus 4 be equal to 4 cos t, such that dx dt is equals to 4 sinh t, and that means that we can substitute for dx with 4 sinh t dt. And so this expression here now becomes the square root of 16 cos squared t minus 16, all that obviously square root, times in place of dx we have 4 sinh t dt. We can pull out the 4, and so we have cos squared t minus 1, and then we still have 4 sinh t dt here. Okay, so our problem now becomes we can pull the 4's out. 4 times 4 we have 16, and then square root of cos squared t minus 1 is the same as sinh t, so we have sinh t times sinh t as the integrand, and then we have 16 integral of sinh squared t. And so using the identity, cos 2t equals to cos squared t plus sinh squared t, which is equals to twice sinh squared t plus 1. Then this sinh squared t can be expressed as cos 2t minus 1 over 2. That's what we're going to do. So we have 16 over cos 2t minus 1 all over 2. And so that reduces to 8 integral of cos 2t minus 1. And so we can go ahead and integrate that. Cos 2t integrated is the same as half sinh 2t. And then 1 obviously integrated is minus, we get minus t. So multiplying 8 across, we have 4 sinh 2t minus 8t plus c, the integration constant. But since we know sinh 2t is the same as 2 sinh t times cos t, we can bring all this in here. So we have 8 sinh t cos t minus 8t. And since sinh t is the same as the square root of cos squared t minus 1, and cos t remains that way, we can go back to our substitution where we had said that x plus 4 equals to 4 cos t. So in place of cos squared t, we 8 times square root of cos squared t minus cos t minus 2t is, so in place of cos squared t we have 8 x plus 4 over squared over 16 minus 1, and then in place of cos t we have x plus 4 over 4, and in place of t we're going to have the arc cosh of x plus 4 over 4. We can simplify this further, and we have, pulling the 16 out, we have 8 over 16 x squared plus 8x plus 16 minus 16, so we have the square root of x squared plus 8x. Then since we have this x plus 4 here, the x plus 4 remains there, and then we have minus 8 arc cosh x plus 4 over 4 plus integration constant. Now obviously that becomes, we can take this up here and we see x plus 4 over 2 times the square root of x squared plus 8x minus 8 arc cosh of x plus 4 over 4. Some people could want to express this arc cosh into something else, like using the natural logarithm. That could be homework for you. You could express this in form of natural logarithm. but we won't go in that direction. We'll leave our answer as it is right now. So that solves problem 15. Let's go on to problem 16. So on problem 16, which is the indefinite integral of the natural logarithm of x over x plus 5 squared. Here we're going to use what we call integration by parts, where if you have the product of two functions, v, and the derivative of function u, and when you integrate that, you get uv, the product of function u and function v, minus the integral of function u times the derivative of function v. So we're going to express this expression in the form that we see here. So natural logarithm of x over x plus 5 squared is the same as natural logarithm of x times the derivative of 1 over x plus 5. So derivative of negative 1 over x plus 5 is the same as 1 plus x5 squared. And so uv becomes negative natural logarithm of x over x plus 5 minus, and that becomes plus 1 over integral of x 1 over x plus 5 times the derivative of natural logarithm of x. And so derivative of natural logarithm of x is 1 over x. So we have negative natural logarithm of x over x plus 5 plus the integral of 1 over x plus 5 times 1 over x. And now we can now separate that into partial fractions. 1 over x plus 5 times 1 over x is the same as a fifth of 1 over x minus 1 over x plus 5. And we can pull the fifth out here so that we have the expression negative natural logarithm of x over x plus 5 plus a fifth times the integral of 1 minus x, 1 over x minus 1 over x plus 5. So we get natural logarithm, negative natural logarithm of x over x plus 5 plus a fifth integral of 1 over x is natural logarithm of x minus a fifth integral of 1 over x plus 5 is natural logarithm of x plus 5. Using the rules of logarithm, this natural logarithm of x and natural logarithm of x plus 5 becomes a fifth, obviously considering the constant, of x, natural logarithm of x over x plus 5. And that is our answer. So we're going to say that the integral, indefinite integral of natural logarithm of x over the square of x plus 5 is the same as negative natural logarithm of x over x plus 5 plus a fifth times the natural logarithm of x over x plus 5 plus the integration constant. On to problem number 17, the indefinite integral of x plus 5 squared times the natural logarithm of x. We use integration by parts again. The integral of the product of function v and the derivative of function u is the same as uv minus the integral of the function u times the derivative of function v. So this becomes the integral of x plus 5 squared times the natural logarithm of x being equal to, we can express x plus 5 squared as the derivative of a third x plus 5 cube. So this means that our integral, our uv becomes a third x plus 5 cubed times the natural logarithm of x minus the integral of 1 over 3 x plus 5 cubed times the derivative of natural logarithm of x. And so a third x plus 5x times the natural logarithm of x minus a third, we pull this constant out, x plus 5 integration x plus 5 cubed times 1 over x, which is the derivative of natural logarithm of x. We can expand x plus 5 cube under the integral sign or the integration sign, and that becomes x cubed plus 15x squared plus 75x plus 125 rather, times 1 over x obviously here, and we multiply 1 over x across, so that it reduces. We'll keep this first part as it is, but that now reduces our integral into 1 over 3 times the integral of x squared plus 15x plus 75 plus 125 over x. Integrating each independent term becomes a third times x over 3, x to the power 3 over 3 plus 15 over 2 times x squared plus 75x plus 125 natural logarithm of x. So we could expand this part and, combine with this component, and we get to see that that is the same as a third x cubed 15x squared plus 75x plus 125 times the natural logarithm of x minus a third. Keep it as it is, but now we see that this minus sign allows this to interact with this, and this cancel out, so that our integral, the integral of the square of x plus 5 times the natural logarithm of x, is x cubed over 3 plus 15x squared plus, actually plus 5x squared, because the 15 divides by 3, plus 25, which is 75 over 3, x times the natural logarithm of x, minus 1 over 18, 2x cubed plus 45x squared plus 450x plus the integration constant. And that happens to be our answer. So problem 18 is the Gaussian integral, the integral from x equals to negative infinity to positive infinity of e to the power negative x squared. This is something that one needs to know by heart, which is the square root of pi. So we won't waste much time there. Problem number 19, which is the indefinite integral of cosine to the power 4x minus sine to the power 4x. Using a difference of two squares, we can express this as the product of the sum of cosine squared x and sine squared x times the difference of cosine squared x and sine squared x. So when that happens, cosine squared x plus sine squared x can be simplified using the identity. Cosine squared x plus sine squared x equals to 1. And so that means that we're left with cosine squared x minus sine squared x integrated. But since we know that cosine 2x is the same as cosine squared x minus sine squared x, that means we are integrating cosine 2x. And that we know when you're integrating cosine 2x, we get negative a half sine 2x. Plus integration constant, obviously. So in other words, the indefinite integral of cosine 4 to the power 4x minus sine to the power 4x is the same as negative a half sine 2x plus the integration constant c. Now, for the final problem in our part 4 series is the indefinite integral of e to the x over 1 plus e to the x. So we can express this, e to the x can be seen to be the derivative of 1 plus e to the x. And so since we have the numerator being the derivative of the denominator, this is a popular thing that we know is the answer here is the natural logarithm of the function, the denominator, so which is natural logarithm of 1 plus e to the x plus the integration constant. And that is the answer. So this sums up the problems that we're proposing today. If you have any questions, please don't hesitate to reach out to us. We'll be very glad to hear from you. If you haven't subscribed to our channel, we'd really encourage you to go subscribe to our channel, because your support will go a long way in helping us improve our channel. Without much ado, we'll end this series here. Until next time, bye bye.